Good afternoon, folks, and a very warm welcome to this main event, as Vikram called it. Let me invite my August panelists to the dais, if you may. Let me start with you, Moore, first, if you don't mind, please. Moore is the CEO and co-founder of AI Fabrics. Before starting the company, he was at Intel for a long time. He's been with Amazon, Cisco, Barefoot Networks, and more. Following Mueon is Eric Norge. Eric, please join us. Eric is the co-founder and the software CTO for Baya Systems. He was at, just like Moore, he was at Intel before, where he got acquired through the NetSpeed, and he's focused on software, which is quite unique because the panelists are mostly from the semi world, so he'll bring a unique perspective, which I look forward to talking to about. Next will be Steve Majors. Steve, if you mind joining us, please. Steve is the Senior Vice President of Engineering at DreamBig Semiconductors, where he leads product strategy, technical execution, and focusing on the chiplet platform. That's another area where I believe there's a frontier approach coming in the market where more and more designs are going to go from 2D to 3D chiplets. I think AI and chiplets are going to converge very quickly, so I'm very, very interested in hearing from Steve. Next up is Piroz Hujabri. Piroz, if you can join us, please. Piroz, well, he happens to be the only RF analog mixed signal guru that we have on the panel. Thank you, Piroz. He's the co-founder and CEO and CTO of IC Photonics. And last but not the least, Wilfred Gomez. Wilfred, please join us. So Wilfred is obviously CEO and co-founder. Before that, he was the Intel Fellow of Microprocessors for a fair amount of time, where he brought on board Intel Foveros 3D platform. Before that, he was at Cadence. Well, thank you very much, folks, for joining us today. And by the way, I have some questions on your behalf that I plan to ask, but I'm hoping you guys will join me in asking harder questions, not the easy ones that I've got lined up for my August panel today. So with that said, let's start. So as obviously, I think Vikram kind of talked about, we are here to talk about building and scaling silicon startup. Well, we're in Silicon Valley, so we're going to talk about silicon startups. Obviously, this panel is a lot more, this AI infra is all about software and silicon, but the focus here is going to be doing more silicon startups. So let me first, reach out to you, Eric, if you don't mind. What's so unique about building a silicon startup versus a software startup? Because you're bringing the software element to it, so it'll be interesting for our audience to hear your perspective.
Yeah, so I've definitely got a software background, and I come at the hardware world, silicon world, and go, wow, there's a huge focus on getting it right the first time. Because tape outs. Everybody in this room knows that you've got to get it right on your tape out, otherwise, well, you're sad. So huge emphasis on validating ahead of time, not in the customer's hands, but in your own hands. Functional correctness, and just the million little things that have to go into building a chip that you have to get right, especially when you're at the bleeding edge. For a startup that wants to push the limits of what's possible and using newer technologies, there's some risks that you have to figure out how to mitigate. And so that's a big difference.
Getting really silicon right the first time. I get that. Mo, what are your views, sir? What do you think?
Yeah, I'll take a slightly different direction. Specifically, we're in the AI infra, and I've been in a few startups before, but I think there's something unique about doing a startup in the context of AI, which is different than doing a silicon startup or a chip startup in different contexts. And I learned that the hard way when I joined AWS in the beginning. Our CTO used to call me a chip head, and that wasn't a compliment. And so I didn't really like it, but after a while, I figured that his complaint was that I was constantly optimizing the chip and not thinking about the system. And in the context of AI, where it's really a distributed system, the chip is a little bit less of the optimization point. It's the wrong optimization point, actually. The optimization point should be at the system level, and to the extreme of sometimes things that are counterintuitive. For example, you can, again, in the context of AI today, people build rack scale, and Jensen, NVIDIA CEO, says that the entire data center is the computer, or many data centers. If you think about it, sometimes you'd actually get a better performance, let's say at a rack, if you have a lower performing chip, but a more power optimized chip because you cram more of those into a rack. And that's a very different optimization than what we think about when we build chips. So again, I think one thing, again, is advice to people who want to look at starting a startup in the context of AI. Don't think about the chip. Think about the system, understand the trade-offs, and they're very complex. They start with the software. We talked about software. But putting aside the software, between compute, memory bandwidth, network bandwidth, these things need to be very tightly coupled and optimized. If you don't get that right, your chip is going to be worthless. So think about it carefully when you plan for your chip.
Okay. Yeah. So, yeah, I take a different view of it because in the world that I live in, we live in a world. What we do is between 50 gigahertz to 85 gigahertz world that we live in. So for us, we start with a package. So the package design for us is the key to success. So in that world, we have to start designing the system at the package level and the thermal. And then from there, we come down to the chip. So chip to us are more a function of the technology that we deploy at the package level, and then we follow that to come down.
Awesome, thank you. Yeah, it's really not working. What it is. You guys can hear me at the back?
Yes.
Awesome. So, well, I mean, I think this will be an interesting conversation going forward, but when I look at talking to a few of you who are here, once you have a brilliant idea, what are the challenges one goes through to kind of start this journey to kind of go from an idea to making to a successful company, whether it's an exit or going public? So what folks tell us is once you have a great idea, well, you need funding to get that idea to market. Then you've got to hire the right people. You've got to have the right EDA infrastructure or a fundamental infrastructure to build out the chip you want. But last but not the least, you have to fundamentally take that product and go to market and reach out to the customer. So the go-to-market motion becomes equally important. So 4 very, very unique but equally important facets that are some of our entrepreneurs' experience. So I would love to hear from them as to how they navigated those 4 elements. So I'm going to query a few of those elements from the Piroz. Let's start with you. Piroz is, as I said earlier on, IC Photonics. So we are hearing 50 gigahertz. So tell us about your startup, Piroz. How did you come up with the idea? And more importantly, how did you get the first set of funding?
Excellent question. So I think for us, our team have spent close to 2 decades designing copper interconnect. And then for about a decade, we have spent it doing optical module connection to different switches and things like that. So we came up with what the bottleneck was in this, both on the copper side and on the fiber side, mainly looking at the single rack. So you can look at it as a scale up. It is mainly copper today. And we see this as an excellent challenge for us to change that paradigm and offer something that is fully differentiated. But it has its own challenges, obviously. But going there, there is really not many. We have not found a single company that have dared to go there and compete with copper. We are there, and we think we have a compelling solution that can put copper out of business in a scale up. So our funding is fairly simple. When you live in the world of 50 to 80 gigahertz, if you still have your limbs attached after being there for 30, 40 years, we have quite a bit of money that we have made ourselves. So we put our money where our mouth is. So we invested in the technology ourselves, and we got it to where we are. And we fully believe that what we have developed is fully differentiated and is a new paradigm in this market.
Awesome. Did you consider going through an incubator, Piroz, or always Angel was the way to go?
Yes, the incubator is actually an excellent question. Incubator for us was very important, but because of the scale of the business that we need, not in the prototype stages, but after as well. So we had to build an ecosystem with partners, starting with EDA companies, with packaging companies, with foundries, with OSATs. But all these are real tier one because we had to scale to the next level fairly quickly. And this ecosystem that we built, it was based on 20 years that we worked with these companies, and they're fully involved in it because we are going somewhere that no one has been there before. So they're trying to build the flows, the ecosystem as we are developing the whole thing.
Trailblazing, sir. Trailblazing indeed.
One more
Go ahead, Matt.
comment on this one. Again, for those trying to raise money and think about it, one thing I've found, it's not very difficult today to get money if you have the AI title in front of you and doing something. But I would certainly discourage people from going down that route. Eventually, you want to be successful, not just raise money. And the amount of people building AI infrastructure or companies doing that is relatively small. I think if you don't have a strategic investor in that mix, chances are probably not very good that this will go very far. So I think looking for that strategic partner is extremely important, and getting them into the mix before you just get money from someone. Money is good, but it takes you so far. You need a little bit more than that.
And if I can add,
Yeah, go ahead.
I think definitely if you say AI, you would get money, but I think that's only limited to software. The moment you say you're building a chip or hardware, it actually drops off. And I'm kidding. I'm not kidding because there's very little appetite for chips, like modern chips. Secondly, it takes a lot of money to build a really good chip. So I think you have to be kind of contemplative where you're coming in from, what problems you're trying to solve. Are you the right team? Are you having the right partners? And I think the way to doing it is first listen to yourself, because I think there's something in the Bible actually, ask and thou shalt receive. So it's very easy to go out and ask for some money, but if you get the wrong money, the wrong partners, the wrong problem, you will sink. So my take on this is very simple. First, be very passionate about what you're trying to do. Then you'll get the right team, the right partners, and then also probably a problem that the world needs. That's how I think you should always think about this.
Thank you, Wilfred. Steve, I mean, you guys are doing multi-die chips. Wilfred just talked about how hard is it to raise money. I mean, can you walk us through what took you to get? Because, I mean, doing an AI startup, doing of all things multi-die chiplets, I mean, that's just bringing to perfect storm. Go ahead, please.
Yeah, it's correct. Very difficult. I will say that, first, I agree with many of the comments that were made. I've experienced those things myself. Specifically to the class of products that you're talking about, it's very important when you know that you're setting out to do something that's not short term. It's going to take some time, right? The investors that you take on in the beginning need to be believers, right? They just fundamentally believe this is the right direction. And then, of course, they have to believe in you. In my case, I had the great fortune that Sahat Sutarja and Weili Dai became those believers. And if you know the history of Sahat at Marvell, he was a pioneer in chiplet, right? So this was a perfect combination. And also the other founder of DreamBig, Sohail Syed, had been a serial entrepreneur and had the trust of Sahat and Weili. But this marriage of a believer and someone that can carry you in the beginning when you're about to do something like this was very important for us. It helped us because it wasn't just about the funding of the work that we were going to do. You need partnerships. If you make chiplets, you need the chiplet to talk to another chiplet, right? You're not going to build all the chiplets and so forth. So that's how we got to where we are.
Great, thank you. So that was a little bit on the funding element. I want to quickly pivot, if you may, talking a little bit about infrastructure, because Wilfred, let's start with you, because you were at Intel, before that you were at Cadence, so you really have figured EDA out, I would imagine, right? I haven't. I'm sure you have. So we'd love to get your view on how difficult was it for you to set up this EDA environment, particularly in early stage startup, because you don't have all the bells and whistles, all the compute you need, all the licenses you need, and the IT CAD resources. So help me understand, particularly you're doing a startup again, and what was the complexity that you were trying to mitigate, and what was your experience?
Yes, well, that's an excellent question. So first of all, what I realized is I came from Cadence, I was at Intel, everything was taken care of for me. I didn't know where the tools came. We had unlimited amount of tools. I think we bought half of Synopsys tools.
Yes.
We had people who would actually provision whatever you wanted. So we started this company. I needed all the same tools. So right there was the first problem. So you cannot start an AI company or a chip company unless you have the best of the best tools. You cannot take a shortcut. You cannot go use free tools. There is no GitHub for something. So you have to have the best tools. Secondly, as you said, you have to have these tools in the cloud because you'll be running things from everything from evaluations to finite element solvers to 3D IC compilers to tape out. So all of us have to run in the cloud. Secondly, it turns out that not just everything can live only in the Synopsys cloud. Some is actually better provisioned in Azure, and some seems to be a bit better in Google, and you have to figure out how will I hit the road running. And so we had to find consultants who could actually go off and provision the right software in the right cloud. But really, it actually came down to one very simple thing. Relationships really matter, and I think the reason it matters is once you ask the right questions and say, this is the framework that I need, and these are the optimizations we want to do. These are the collaborations we can do. Your partners show up for you. And actually that I think was a transformation for us because in this particular journey, helping us set up the cloud, like initially, just evaluating what features are there, having it right on day one, then obviously the team actually provisioning. Secondly, I do want to say this, not like no company has all the tools. I mean, like that is, it's like really how do you make that marriage work? Like so on that front, I was really fortunate that I have I was able to have I have in my company folks have pushed the limits of EDA, and this is where I'm looking this collaboration is very special to us.
Great. Thank you. I mean, Wilfred, you talked about, you've done design at Intel, etc. Some real complex one. Ponte Vecchio was one of the first trailblazer multi-chip design we did. So obviously, without divulging too much into what Mueon is up to, but would you give us some color on when you have a complexity of the design, how does that drive the decision-making to put together a infrastructure around to get your job done much faster, much easier?
So we did a tour of almost all the major, is that working or not working? Okay.
I'm making it work.
Okay. So we talked to many of the hyperscalers, the AI companies, and all of them are struggling with three things. Challenges of designing with a modern process, multi-chip design, power and thermals. And the issue right now is, if you were to go back and look at Ponte Vecchio, when it was actually designed, we did not have all the CAD, because the CAD was getting created. In fact, some of the 3D IC CAD that went into Synopsys came on the blood that we actually shed, So what really happens in the first kind of products, things don't work, and the issues are the supply chains are not ready, the yields are not good, the tools really do not give you the right color of the health of the silicon. And so what I found is, through that Ponte Vecchio experience, you really need really good reduced order models for everything. What I mean by that is thermals, electricals, warpage, package design, even just supply chain modeling. So what we are changing going forward is, you don't have to design everything, but you have to have first order principles. Would this design work? Would this supply chain work? Would this process work? And when it all comes together, is this a product I want to build? And that's, I think, the capability that is missing, and which I think will get developed. We are kind of going to pioneer some of it, but to really make chiplets work, you need this kind of tools to come together. And I think that has been my biggest learning. you don't have to go through and get a chip out. You have to be able to model it and do it quickly, many times, to very high confidence.
Yeah, I think that's a, go ahead, please, go ahead, please.
Yeah, so on the cloud that you mentioned, our experience have been on a cloud-based solution, because a lot of the things that we do is really high frequency, is under U.S. export control. So the environment has to be secure. So we have had a lot of attack on different places that we have worked on that environment, and for past 6 years we have been with Oracle. And from a security point of view, I can tell you that we have survived all the attacks that has happened. So excellent. And then on the other side, our partnership with Ansys for past 15 years to be able to produce chips above 50 gigahertz when we get the silicon within 3% of what we have designed has been critical. Not only the design of them, but throughout our supply chain, all the way to the package, to OSAT, they all have the same, they use Ansys toolset. So we can talk to them in the same language, send files to them, and get things back and forth, and validate the entire supply chain, not just the design of the chip, but because it's really an ecosystem that you have to manage at these frequencies.
Right. Well, thank you. I mean, so is Sterling still here, Sterling? Sterling took off? Well, Sterling, thank you for calling us serial acquirers. We got serial entrepreneurs over here. So for those of you who have not picked up the news, but Synopsys closed the acquisition of Ansys. So Ansys will be available on cloud. Please reach out to Vikram, who's here. And if you need some more information on Ansys availability on cloud, I think we can answer some of the questions as well. More, I mean, you've been with the Synopsys Cloud for a while. What's your take, particularly on the infrastructure, complexity, and scaling challenge, and what's been your learning so far?
Yeah, I've been listening carefully to the inputs here. Obviously, I agree with most of what was said, but my biggest thing about the experience with Synopsys is summarized by I don't need to have an umbrella. And the reason for that is because when I did another startup, I was at Barefoot Networks before. We did our own IT. We were really in a garage in Palo Alto, and it was raining quite heavily, and it started pouring on the servers, and we had to run with umbrellas to save a year's worth of IP that we were desperate to keep. That was a horrible experience, and that's why from day one, when we started the company, we said we're going to do it in the cloud, trust the people who know how to do it, hosting it, giving the tools. And it's been an excellent experience. Really, I sleep well at night, and I did not sleep well at night there. And this is, again, by the way, even pricing, usually people say cloud is more expensive, this and that. My experience at least has been, if it's under control and you have the right knobs to make sure that people don't abuse the cloud, because it's very easy to do, you actually end up with a cheaper solution than if you build your own infrastructure and maintain it and over-provision it and so on and so forth. So again, our experience has been very good. We started it with day one just because of the umbrella situation, and we'll continue using it. I don't think we're going to move to our own IT anytime soon.
Well, I mean, that's been a common theme, at least I've heard. Thank you for that. More we've seen that feedback consistently, that we want entrepreneurs to focus on design and the intent and not worry about infrastructure and CAD and tools and compute, because while it's important, but I think we can get distracted because the focus should be the North Star, if you may, should be the design and the design intent going forward. I will be amiss if I don't talk about generative AI and agents, etc., coming forward. So this is for all of you, and I'll let one of you take the lead on it. How do you guys envision your company leveraging AI or generative AI, particularly with EDA vendors like Synopsys, to help you further improve your productivity and reduce your overall, we'll call it, total cost of ownership? Whitford, do you want to go first?
Yeah, I can. So first of all, I've been really fortunate to be at almost all the transitions that happened in the EDA industry. 90s, I started logic synthesis, and our team thought, you worked very hard, you could transition custom design to RTL and logic synthesis. We made that happen. 2000s, chiplets started. Chiplets are big. late 2020s, 3D stacking. 3D stacking is everywhere. I've been there. The future is really system design. And let me tell you what and why AI and system design go well together. If I were to talk to a designer today, he knows how RTL is done, how a gate is designed, maybe a little bit of custom design, but they do not really know what happens in the cloud, where a network is. There may be some network experts. The future designer needs to have a really holistic view of the entire system because, as Jensen said, the data center is a customer, is a computer. But that's a huge scale of knowledge that no human can actually get to the bottom of, and this is where AI comes in. And I see this in our, at Mueon, we are looking at different designs, different topologies, different materials. We are looking at different fabs, different lithography schemes. Not just because we're just looking at what's coming, and from morning to evening, we can evaluate hundreds and hundreds of experiments, and by the end of the day, we actually could. This is at least the team that I have. We could evaluate and build, and say, hey, if we were to go down and build this actually could be a useful computer to build. This could not have happened 2 years back without AI. And what I see is things like coding, writing RTL. It's just become anybody could do it. But really, where's the hard physics? Where are the hard thermal limits? Where are the hard material limits? Where are the hard transistor limits? Actually, I can ask my team, and they could come back in up to 2 hours of study and say, yep, if I were to put a bit of focus here, we could get our partner to change it. And that's what AI is doing for me.
Awesome. How about you, Piros?
Yes. So actually, from an AI point of view, I'm an RF designer by experience, but at Synopsys, I've been amazed that I can actually use the core consultancy, or core kit, or code build that Synopsys calls it. I call it AI agents.
Right.
Mainly, I can sit there because on the electrical side, we have a lot of customers and they all have different requirements. I can go to this tool and pretty much draw the entire diagram with all the IPs that Synopsys has, because you don't want to really reinvent the wheel. If the thing exists, why do I need to spend resources on my side to actually develop this, right? So this is amazing. As an RF designer, I can sit there and be an architect. Right. And so in my company, we have a couple of digital guys. So with this core consultant, not only I can get the entire RTL, I can get the test bench, I can get the vectors, and within a week I can validate and show the customer, is this what you want, right? And the speed that I can do this and time to market, because every customer that I have, that the digital side, the interface, electrical interface is different. And for all these chiplets, I can modify this, in less than a month. So it's amazing what Synopsys is able to do.
Go ahead, please.
I do want to add one thing. By the way, AI, I think, is the ultimate democratizer or leveling ground between a small company, a startup, and a big company. In fact, if you're a really big company, the speed at which you could move slowed down by many, many different things. A small company with AI agents and you could actually be at the same velocity as a big company. That's what I think.
No, I agree. I think between the haves and the have-nots, I think the AI can be a big equalizer.
Yeah.
How about you, Steve? What do you read?
Yeah, I think that even though we are a silicon company at heart and building, as you mentioned, complex systems out of chiplets, what I've found is that we've been able to be successful applying AI in our product development more from the system and software side. We have a lot of software stacks that run on our hardware. That's helped us learn how to use AI in something that was easier for it to help with, right? And then the next thing that is needed, it was mentioned at the early on in the panel talk, we can't have verification be a bug finder anymore, right? We need to prevent bugs, So it's not just that if, you can still know the system spec at the beginning, you can have a good definitional partner, and so forth. And if you find a significant microarchitectural bug late, that's a big problem, right? So, and I think AI is the only thing that can do this for us with the complexity of the designs that we're doing. But I would like to see that be the first area of EDA where it's really applied.
Maury was saying something?
Yeah,
Go ahead.
one comment on this one. Again, from our experience, first of all, I think the potential is huge, and obviously, eventually we'll get to silicon design too. But at least in the area of silicon design, when we started, again, we had these cool ideas and directions that we wanted to take. One of them was heavy use of AI-assisted and automated design verification. I have to admit, a big failure. Up till now, we tried quite a few different options, including from Synopsys, unfortunately. And it's not quite there. Not for silicon design, at least. And I'm talking probably a year ago. So maybe in the last year, there's been a huge leap, which we didn't catch on. But I think we need to continue investing and getting it there. From what I hear on the software side, it's doing a much, much better job. And I think we need to catch up. I think there's a good reason why. There's much more open source software to learn from than there is open source RTL or DV or UVM or whatever. But really, the results that we have, we work both with innovative startups, bigger companies, all sorts of tools. Some of them work, but don't really give you much value. And most of them actually don't work, and you spend more time debugging them than getting any value. So I would certainly, at least again in the short term, take it with a grain of salt on how much we can leverage. But long term, I think for Synopsys and other companies, is a huge area for investment, and we would certainly like to use it as much as possible. We actually try to engage with the R&D team to get us what we need, but it's a long engagement, it's a long development process. It's not, at least again, a year ago it wasn't there.
Eric, you're the software guy.
So Baya is relatively conservative in this. We're optimistic. It's good for many things that we're doing. It's not a cure-all. We can't just sprinkle AI magic on our development process and magically things are fixed. We still have to do a lot of real work in thinking what to ask for, what to do, to move the AI through step by step. And it helps with repetitive processes. There are many things that it's great having it there helping me out and going, oh, did you want this? And great, okay. Some small things are improved. End to end, I'm not as sure that it's going to do a big thing for us. We do leverage AI, machine learning in our product, but for helping the users understand our documentation and interact with that in a way that is not on the critical path to them taping out. Because we've tried it on the critical path and it is able to hallucinate better than we're able to guide it.
Yeah, I mean, from our vantage point, sorry to say, but real quick, from our vantage point, I mean, from the EDA perspective, if you may, while we have made enormous amount of improvement in the core product, but by the nature of the beast, it's a very iterative process. You're always going to trade off between coverage and pattern count, or area and performance.
That's right.
So if you have an area where there's going to be iterative or high toil, that's where AI can really come in and help. And so we've pioneered some work with reinforced learning earlier on. Then we talked about, whether it's verification or it's implementation or it's analog. We moved from there to more on the generative stuff, which is the large language models. We're talking about how can you assist, and then how can you be a co-pilot instead of being a pilot. And then now we've got the new frontier with agent stuff coming out. That's where it's moving so rapidly. And I personally, obviously, am from EDA, so I believe that we are really prime time that can really benefit. And that's where the compute, the optionality of large language models, what kind of provisioning you do, I think cloud will offer a beautiful opportunity to be able to exploit all the benefits what AI will bring. Sorry, Steve, didn't mean to cut you off. I just had to get my 2 cents in.
I appreciate it. Yeah, I just wanted to clarify. What I'm saying is that it sounds like all of us have had a positive experience using AI for some kind of software development activity. What I'm saying is my advice to Synopsys would be instead of investing in a peanut butter way across all of your EDA tools, right? Focus on the areas that are more like software, and verification is software.
That's correct.
It's not hardware. And I think you'll have the most success, and I think you'll make the biggest impact.
Great, thank you for the input. Go ahead.
I think, and this is something I do want to say, not everything in chip design is the highest performance. Like you have fuses, debug signals, sideband, clocks, controllers. And I think what I'm saying is the more that gets automated, AI, agents can be done automatically. The designer can focus on the fundamental algorithms and just get the rest of the system built. And I see that happening. Secondly, I think there's a lot of documentation. For example, I was just trying to query, I had to find, like a microarchitecture spec, and just the fact that an AI system can summarize for me what the registers are and gets the obscurity out actually is a huge step forward. I don't have to go find an engineer who might not exist in the company anymore or hunt down somewhere. It all, like fingertips. So that's...
No, I agree. I think there's a huge... Go ahead, Eric, please.
So I'm going to respond to the first half of what you said, because that brings up a thought of mine. And this might be controversial, it might be entirely wrong, but you're welcome to correct me here. So software used to be written in assembly. Well, we used to toggle things, but we used to do very low-level things in order to get the most performance out of our software. And we've moved to way, way, way away from that. We're eating up all of the gains that the hardware folks are giving us. You give us a faster processor and we just slow down our software. But we gain benefits from that. And I'm suspecting that Moore's law is going to keep on going for at least a little while longer. And we're going to have more transistors than we're going to know what to do with. And we won't have to be optimal with every single transistor. And so there may be a time when these types of technologies that give you more productivity in development will be more applicable in hardware, that you don't have to optimize every single gate. We're not doing that anymore, but we're still pretty close to that. And it seems like hardware, silicon design is still very close to that. And I look forward to the abstraction levels going up and up for hardware development. For silicon.
Can I add something?
Go ahead, please.
This is actually pretty interesting because, using this AI agent.
And this is a startup idea right here.
There you go. Please take copious notes.
Exactly. This AI agent, I've stopped using ChatGPT and, Copilot and Gemini. For chip design, I use these AI agents. And they understand exactly what I need. And they give me the block diagram in less than a couple hours. And I can look at it and I can understand exactly what it is and what I need to do. So for me, this is the AI engine that I need to have. Right? So like the AI engine for chip design, being able to figure out your interfaces, being able to figure out your all the IPs that exist out there that I don't have to develop inside the company, I think is the critical. So I call it another AI engine that, for my work is critical.
Nice. Well, so let's pivot. Now that you have talked about AI, I bet you next question would be, do you still need to hire that many people? Because you have AI now. AI is going to be complementing a lot of talent. So let's move to the hiring element of getting good talent on board. So it's a different type of challenge. It's not necessarily unique to startups, particularly what's going on in our industry at the moment. So Eric, I'll come to you on this. Since you've been looking at hiring expertise across digital, AMS, software, packaging, walk us through, what did you go through when you were putting together this A++ team?
It's still hard to get an A++ team. There's a lot of A++ people out there, but they want to stay where they're at. They want to be paid huge salaries, and they want the comfort of working for a big company, as opposed to the stress and complexity of a startup. You find the ones that are willing to change. They find the ones that are really interested in challenge and give them that opportunity instead of that threat. You work your network a lot. you know people that know people. There are specialized recruiters out there. They can be okay, but they can be very hit or miss as well.
Yeah, let me give you the analogy, Eric, if you don't mind, of a classic spider web. You'll have an inner circle, which is the founders, and that helps you drive going to the venture community and trying to get funding done, etc. Then you build the outer ring out. Walk us through, your initial team, how that helped. You got the prototype, if you may, got the funding. Now you're going to scale out. Walk us through that, please.
Our initial team was absolutely critical for getting VC funding. We had to look at a lot of venture capitalists, and we were not happy with the first few, and they were not happy with us. There's a lot of them that don't want to invest in hardware startups. You keep going until you find the right one. There are VCs out there that know where the money's going to be, and that are willing to make the appropriate bets in this world. In the silicon world. Having a lot of experience is a huge thing for VCs. If you've been successful in the past, that helps a whole lot. And so building from that core team, being able to get venture capital funding, we just one at a time. Like we built our prototype, we built our first version of the product, and then expanded the team to include the necessary sales and application engineering and larger engineering side of the company, spider webbing out, and we're still continuing that growth.
Awesome.
One thing I want to add on team building as such, I've certainly a very big challenge, let's say, for startups, given the environment you described. But one thing at least we've noticed, there is a non-trivial amount of people who are extremely frustrated from being very capable, but in a big company, where their capabilities are not fully utilized, to put it mildly. And some of us came from Intel, we know even worse than that. So there's actually a very big pool of people to tap into. You do need to find your way to getting to those frustrated individuals that are very capable. But again, in a startup, you're not going to build a big team either. You're going to have a relatively small team, order of magnitude probably lower than what it would be in a bigger company. So I think assuming that you can't extract people from these high-flying companies is not the right way to think about it. We've been able to hire from Google, from Meta, from anywhere you want. And these are high-paying. And by the way, in many cases, people come to us taking a non-trivial cut in their pay because, first of all, they believe in the company, but second, because they also believe that financially over time it will benefit them, and career-wise, they will actually grow much more significantly than they would by staying in a bigger company. And there are quite a few people like that. They start off going after the money with these big companies, but very quickly get frustrated and look for the startups, actually.
So, Sanjay, something you said that it resonated with me. Exactly, that's what's happening to us. And that is, we have, in our company, because there's different discipline, we have point experts. So people that are expert in different areas. But for amplification of that, we use this AI agent. So the AI agent is really allows us to scale. You cannot replace the point experts, but with that, we don't need to hire an army of people behind them. So one point that we looked at is that how much for every dollar that we invest, because of the ecosystem that we have and these AI agent, we're roughly getting 30x amplification for every dollar.
Vikram, you're pricing information right here. Keep going, Pero. I love you, Frost. Keep going. I like what you're saying.
And this is real. I think Sylvie has done the analysis on it, and she's actually showing that impact to us now.
Awesome.
And we are amazed.
Great. Guru, you had something to add?
I think, by the way, these are excellent points. And if you're a startup, you should assume hiring is difficult. Good people are rated. I think this is where you have to find partners. And I think it's not really clear that they have to be, like your employees. You find good partners. Really, you have to find, like EDA partners, hyperscaler partners, fab partners. And the first thing is, even before you do an ounce of work, validate your solution, get it to a point where you believe that it has a good chance of success. And that, I think, is like a very hard part of a startup. And I think that's, if you were to put a lot of time into that, that's where I think you need to get as much time from your potential partners and your customers. And that's, I think, is really important.
So, I want to build on the question. I'll come to Eric in a minute. But more you talked about the frustrated class, if you may, folks. What, if the audience here, what advice would you give them? How do you tap into that pool? It's not on LinkedIn, clearly.
No, it's not on LinkedIn. And by the way, we tried LinkedIn, and it was horrible because I got hundreds and thousands of people who, very hard, we don't have the bandwidth to be able to interview everyone. So LinkedIn, at least for us, didn't work very well. What we actually found very useful is actually specialized recruiters, which again might backfire on us, but they seem to have placed people in these places. They have a good understanding of what we're looking for and a good pool of people that they know are capable, talented, and so on. And they go back to them and tell them, hey, how are things going? Are you interested in looking for something new? And I would say a good 50% of them turn up to be a yes, and then we engage with them. Now, I hope it won't backfire because I'm sure they will continue to talk to them. But again, to me, it's actually a non-negative thing because if they're happy, they won't leave. If they're not happy, maybe they should leave because, again, to me, a big part of the success of a startup is having an energized team that is fully engaged, happy, and working as a team to get things done. If we have people inside who are not in that space, then yeah, maybe they shouldn't be there. So that's primarily. We actually ended up going with one or two key recruiters who tapped into people that they know, and we have a pretty good success in going that way.
Eric, you were saying something? Go ahead, please.
Yeah, I just have to introduce the concept of contractors into this discussion because you have to make do with less money, and our user interface was miserable until we got a contractor, and they made it beautiful, and we're like, oh, we couldn't have built that. We needed somebody, and we don't still need them for a whole lot.
Stretch the dollar.
Yeah.
Stretch the dollar. Got it. So let me move on to the last part that we touched upon, the challenges. Something that's closer to my heart is particularly a go-to-market element of it. So Steve, first of all, congratulations on raising Series B. Looks like you guys have publicly talked about it. And you probably have some real fascinating insights on market adoption because you've been fairly public. Would you mind walking us through some of that, please?
Yeah, I think for us, what became essential in Series B is to have that strategic partner. For DreamBig publicly, that's Synopsys. It helped us in a number of ways. First of all, we learned that that strategic partner is a draw, right? It's much like building a shopping mall and you have an anchor store and then all the smaller stores come. So that was very critical for us. Can you repeat your question? I'm sorry. I remembered the first part.
Fundamentally, I was talking about, Series B just recently closed, and what have been your market insights? Because you've been through this journey. What have you learned in terms of your overall taking the product out, publicly talk to your customers?
Yeah.
Just the go-to-market element of it.
Yeah. The go-to-market part is it's a little bit analogous to the hiring. There are customers that are traditional, meaning they're going to tell you, until you show me silicon, I can't really talk to you. Right? I'm interested in your idea, but I can't really do anything with you that's meaningful. Right? But you will find customers that you're solving a fundamental problem that is so critical to them, and they don't have a solution currently, or they need to create their own solution. And because of that customer strategic alignment, they want to work with you. Right? They're not necessarily investing in you, but at that stage for us, when we were raising the B round, we were able to find customers like that, ones that we've made public and others that we haven't. So I think it's just a matter of what stage are you in and what kind of go-to-market are you needing to do.
No, great. I mean, even as a publicly traded company, whenever we put out a new product, you don't go and engage with hundreds of them day one because then you boil the ocean. So you always want to roll this out, proverbial, bowling pin alley analogy. Pick up your first two ones who you can partner with, who can improvise, help you improve the product, and then you slowly kind of scale up. Was that your experience as well, Steve?
Yeah, definitely. And they have partners.
Right.
They bring you into their partners. It really cascades.
Got it. Eric, what's been your experience with Baya?
pretty similar. Initial customers and how you engage with them, and finding ones that are willing to not just take a risk on you, but work with you on refining the product is critical for what we're doing as an IP company. It might be a little bit more difficult to do as a chip company because, well, you have to decide what you're keeping out. Yeah, exactly. At some point, the development stops, and you work on version 2. But similar process of knowing the requirements and working towards those requirements. You have to understand your market in order to build a product that will fit it. And there's no substitute for just getting out there and understanding customers' pain.
I mean, can you guys walk us through, how do you choose that first proverbial bowling pin? I'll come to you more on this. That, hey, is this a partner who will help me refine or redefine my product? Or is this a partner that has got such influence in the ecosystem that they can really be pulled through for my technology? Walk us through what goes through your mind when you choose. More one coming your way, sir.
Yeah, I'll need to be careful in the way I describe it because we're under stealth and
Sure.
a lot of the information is not public. But in general, and maybe I'll draw back on other experiences that I had, especially again in the area of AI, at least my personal belief is you need that strategic partner who will do primarily 2 things, I think, for you. One is they will guide you in the right direction on something that may not be generically applicable, but certainly applicable to them, so that at least if you do a good job with that, there's a good chance they will be a customer. I think that's one important thing. And obviously you want a big customer in that sense. The other one is that they will be able to open up doors to get you into a wider market. But again, in the context of AI, I have to say, at least in the infrastructure space that we're operating in, most of these people that we're talking about, first of all, there are a few, and they actually compete with each other. So I don't think they're opening any doors for us anytime soon. But again, I think the key thing is you need, at the minimum, to make sure that the partner, the strategic partner that you have, has enough understanding and clout to be able to guide you in the right direction. And after that, hopefully, become a customer. I think these are 2 key things that I would look for at the minimum with strategic partners that you'd want to partner with. Yeah.
Wilfred, what do you think?
So I think you want to go? No, go ahead. I think there are the 3 things here. First, the funding itself. I think it's really good if the funding came from one of these partners because they would be very interested in opening doors, showing you the way. So I think that's a key one. So make sure that you get funding, or if you can, get some support from a good partner. That I think is number 1. Second is just like how Synopsys and Cadence and all these EDA vendors are good partners with everybody. You need to find a footing where you actually get a beachhead. Like the reason this beachhead is really important is you need to get started on something that you can grow, you can have a flywheel, and you can compound every day. So finding your reason for existence is super important. So it has to be something really simple. It can't be boiling the ocean. A startup should really be based on just one simple idea where everybody unifies, and like you can say it in a 3-second pitch in an elevator. That's the second thing, and you can take it to any of your partners, and they would say, "Yep, I would support you if you were to do X, Y, and Z." And you say, "Okay, I've done X, I'm going to do Y." The third thing is everything is like milestone based, and this is where I think this presentation from Plug and Play from Synopsys. Everything that we do in a startup or in any is milestone based. You set reasonable expectations. You don't shoot for the moon. The more reasonable you are, the more trusted you are. In fact, what I found is in this journey, the lesser you promise, the more you're trusted. Actually, like the most important thing is, can you just show up and say, "I want to hear your problems, and let's work out a problem that is like mutually agreeable," instead of saying, "I can solve like world hunger." So being very modest and like trying to understand the customer's problem is the third important thing. And that's so my advice to all of you is find a good partner who'll be through find a flywheel that you can say in a 3-second pitch, and be very modest about, like what do you want to achieve. And every one of you here could have your own startups.
Under promise and over deliver. Spoken like a true fellow.
Yeah.
Piroz, how about you?
Yeah, so something you said is kind of, we have had similar experiences. So I think it's the key that you define an application that really changes the ROI for your customer. And it has to be compelling enough that your customer agrees that this is like a paradigm shift. But the other thing that I can tell you is that at least in what we do, because it involves optical and involves lasers. So when you want to go scale up and replace all the coppers, because copper is fairly cost effective today in deployment. So the first thing we have done is like having a laser that can handle the entire rack. So that means there's a pretty high powered laser that we are connecting to the entire rack. So safety, redundancy, so you don't blind anybody, this thing doesn't get out of hand. It is something that we as somebody that has dealt with it is very important to us, right? But then at the same time, it scared the hell out of the end user that, oh, I'm going to take all these copper that is fairly inexpensive, replace it with this, and I have to worry about all the safeties, all the other things that you're talking about. Am I going to be able to deploy this, right? So for us, we have to make sure that it's not just a piece of technology that you're throwing out there. It has to be something that is deployable and something
Scalable,
that is safe, that is reliable.
Got it. Go ahead, Steve.
I just want to quickly connect 2 points of discussion that you brought up. This last one about Synopsys supporting DreamBig, but during that journey with Synopsys and Samsung, right? And we were doing 3D chiplet development specifically. You need 3D IC compiler. It's extremely helpful, but you also need a lot of technology information to be put into that tool, right? And we got excellent support, like a co-partnership as a result of our relationship with Samsung, your relationship with Samsung, and both with us. That turned out to be a very beneficial experience for us.
Right, great. Well, one other thing I think I should have captured before, but in addition to funding, infrastructure, finding the right people, go-to-market motion, I think the common thread I'm hearing is having a robust ecosystem. Be it ecosystem of suppliers, be it partners, be it vendors, be it customers. And I use the word loosely, but it'll take a village to get this thing. And you have to have these trusted agents, if I may, who are looking out for your and their, of course, mutual win, but making sure it's a win-win for both. So that's one of the elements that I think I'll make note that we'll continue to discuss more. I want to open up a little bit for the floor. We've got a few minutes, and I would love to have a few more questions on the floor before I ask you guys to give some closing remarks. So any questions on the floor, please? It's not that hard. Look at me. Go ahead, Vikram. Charity begins at home.
Here you go. Take your mic. I'll take his. All right. Yeah, so I had a couple of questions. The first one was on hiring. And it's coming from me running into a lot of young kids and fresh grads at these conferences, right? So we were at DAC a few months ago. We are here today. What's your take on hiring fresh grad engineers from good schools, right? San Diego, Berkeley, whatever, UCLA. And honestly, like, what should they do to get hired? Because what we are hearing is the job market has really tanked for them. I know it's happening in computer science. I know it's happening in core engineering. So what's your take on hiring young kids?
I can answer that.
Please.
Yeah, because unlike AI agent that we are using on the digital side from Synopsys, on the RF side, there is not much AI agent that you guys have deployed so far. So hopefully with Ansys acquisition, that can change. We do use a lot of fresh out of college, the PhD level, that are RF graduates. And really there is mainly to keep up with our point expert. So they have a lot of interest to, a lot of them are hungry to learn, and they put a lot of effort to keep up with, because we have some of the best world-class people in our team. At least I'm prejudiced enough that's what I think. And when they talk to these guys, they all are interested to put the effort to get to that point as quickly as possible, because that's what the startup offers them.
So Piruz, I'll just expand on a little bit, right? So because of what I hear, fresh grads, whether grad school, grad degrees, or undergrad degrees, right? It's very hard for them to find you guys.
So I can take this.
Please.
So actually, first of all, if you want a job, send me an email, we'll talk. The way we used to do this, and I'm actually, I found this as a really good BKM. This was again back at Intel, and I used to sponsor, sorry, can you hear me? I used to sponsor several professors, their work at different universities, and the grad students that actually did the work. So we are continuing that at Mueon. So we found really good university programs which are very particular to what we are doing, and we're actually sponsoring the work. And what that really means is PhD students, their stipends, the work that goes in, and the professors. So that I think is a really good pipeline, because not only is it a one-off thing, it actually sets like really grassroots. So my BKM is establish really good relationships with the universities you talked about, find good synergies, and then keep growing it. And obviously, if you have good resumes, always looking for people who can walk up, up waterfalls in memory, materials, advanced processes. Send me your resume, and we'll talk.
Wilfred Gomez at callmeanytime.com.
Yes.
Yeah, exactly. No, but
especially memory.
To answer your question, I think the way we go about it is, I'm on the UC advisory board for electrical engineering. So we get the top 3-4% of the graduating class every year. So across the UC system, but then at the same time in University of Michigan, University of Pennsylvania, we get candidates from there as well, top 3 to 5%, because it really you need people that are not only I think to know the art is one thing. I think is more like 30%. 70% is the interest. They need to be hungry enough to advance and to learn. So we look for those type of people, and from the professors are the best people that can tell us who those people are, and we go after those, because if they don't have real interest in what we do, you can't really force people by just paying them money or shares to interest them. So if they're really interested and they get to spend time with somebody that is a master at the state of the art, to them is like they hug this, they love it, and they jump on it.
Very good point. Okay, I'm going to do a follow. Let me pass it on. We got interest.
Hi, gentlemen. Keith Koo, a Silicon Valley Insider and an investment banker with U.S. Capital. So we're about the same generation. Real question is, how realistic, so hardware and semi versus software, if we have all that experience, how realistic is it for early stage, like first-time founders? Because it sounds like most of you have exited, we've exited, right? So what is your realistic advice to early stage young founder to get into hardware and chips? How realistic is it for them to exit?
I can take that. This is my first startup, never done, first-time founder. I think software, and I have several founders who, created software startup, Baya Systems. It all depends, I think, on, the problem you take. Really hard, challenging software problems, difficult to, fund. Easy hardware startups, very interesting, easy to think. Hard physics problem, very difficult to, fund. But here's the thing which I think is always possible. You have to start with a really good wide network. There is no cold calling in this business. In fact, you have to know someone who knows someone who knows someone, and that is really like, you have to get your foot into the door. The fact that we're good partners with Synopsys, good partners with the foundries. Essentially what will happen is, if anybody would want to put money, they would do 10 reference checks, like say, hey, what's this person's track record? Has he done? So you just have to be very sure that, what you're claiming is what you're doing and all of that. But it is all doable, because you see examples, all these are, except one hardware startup, so it's possible.
I'd say when you start a company, there are usually multiple founders, and they each play a different role. So if your question is whether young people can start a silicon startup, is that realistic? I think for some roles of the founding team, yes. But I wouldn't advise for the lead engineer, let's say, to be one guy that went out of school. I at least personally, first of all, you can see the average age of people sitting here, or the people sitting in this room. I think it's a little bit of a stretch to expect someone coming out of school who can probably start a good software startup and be very successful, as we've seen many, to do the same thing on the engineering side for silicon. I think there's a little bit more runway that you need to be able to do that successful on the silicon side, but it doesn't mean that they cannot start a startup with the right co-founders and one of them can take care of engineering. Maybe he's going to be the older guy in the pack. But other than that, I don't think there should be any limitation in terms of age.
Yeah, I agree with Moore. I think this is the answer, the fundamental answer to the question earlier of what's the difference between a hardware startup and a software startup. It is the experience. You have to have some scars.
PTSD.
I would describe it maybe that the hardware ecosystem, there's a lot more cultural knowledge. There's a lot less that's explicitly taught. There's just so much that you have to know how it works in order to be a good hardware engineer. There's a lot that you have to know in order to be a good software engineer, but there's a lot that's hidden from you, and that's great.
It's the cost of a mistake.
Yes.
Right?
Exactly.
So.
Yeah, but one thing is that what you said, the cost and the scars. Like, I would never do this again. I've done like 3-4 startup, and this is, believe me,
I don't believe you.
This is not something I was looking forward to do. But the team and the pleasure of working with these guys on daily basis. This is like a dream team. So they forced me to do this one more time, and believe me, it wasn't. I didn't volunteer for this, but at the end, it is fun. I mean, spending every day with them, I'm having a lot of fun with them, regardless of the pain.
There's something that I found about Silicon Valley. There's a surprising culture of mentorship here. And so young people that are really interested in getting into this, you don't have a network, that's going to be a problem. But you can find somebody, and you can find somebody that believes in you, that will work with you, even if they're not part of your company necessarily, to help you get into this world, because it's a small world and a bit of a closed world, but there's people that want to share that.
Yeah, we have come this far on shoulders of many giants.
Yes.
I think we owe it to the community. I think that's what plug and play, all these incubators are all about. So I think we owe it back. So great point, Eric. Thank you.
I think just one last point. If a young engineer came to me and said, I really want to start my own startup, can I work for your startup to learn how to do it? That would be very impressive to hire that young engineer, right? If that's their mindset, that would be a way for a young person coming out of college to get ahead in this.
Cool. I think we are at the top of the hour here. And so, do you have a question? No?
Really hard in here.
Okay, cool. I think there is going to be a networking event. I think that's when we should be asking these questions. So, any last parting comments before we wrap up, guys? Otherwise, sincerely appreciate your time. Thank you so much. I hope
Thank you, Sanjay.
the folks enjoyed the
Thank you,
conversation.
Sanjay.
Thank you. Thank you.